Question 11 is about Maxwell-Boltzmann distribution curves. Which statement is correct for the distribution curve of molecular energies in a gas? Now I've got two curves here. So I've got one where it's just at a temperature, and I've shown you the most probable energy and the average energy, and notice the average energy is slightly to the right of the most probable energy. And then I've got three different curves for cold, medium and hot, and notice the cold gas, the peak, the most probable energy is to the left of the medium curve peak that's suppose in the middle in energy, and the hot gas is to the right. And notice at a cold gas the peak is higher, medium gas medium, and at a medium temperature the peak is lower. And that's so the area underneath the curve stays the same each time. Notice they all go through the origin because no particles have zero energy, and they should never touch the x-axis again. I notice a couple of the graphs there do actually touch the x-axis, but they should never touch the x-axis again because there's always some particles with a very high energy irrespective of what temperature it is. So let's have a look which one is correct. 11a, the curve is symmetrical about the maximum. No, it's not symmetrical at all. There's no line of symmetry at all. There are always some molecules with zero energy. No, there are no molecules with zero energy. You'd have to get it right down to absolute zero, which hasn't been achieved, which is not possible for the particles to have zero energy. So there's always some particles with there's always all of the particles have some energy. No particles have no energy at all, so it goes through 0, 0. The position of the maximum of the curve is not dependent on the temperature. No, the position of the maximum of the curve does change with the temperature, and it goes to the right hand side as it gets hotter as you increase the temperature. So it must be answer D. D, the mean energy of the molecules is greater than the most probable energy of the molecules. Yes, it is. So if you look here, the average is to the right of the most probable energy. Question 12. When 1 mole of ammonia is heated to a given temperature, 50% of it dissociates and the following equilibrium is reached. What is the total amount in moles of gas in this equilibrium mixture? So when 1 mole of ammonia is heated, 50% of it dissociates, so half of it dissociates and half of it stays behind. 1 mole would make half a mole of nitrogen and 1.5 moles of hydrogen. So half a mole will make a quarter of a mole and 3/4 of a mole of hydrogen. So 1 mole of ammonia is going to make half a mole of nitrogen and 1.5 moles of hydrogen. So half a mole, 50% of a mole, would make 0.25, a quarter of a mole of nitrogen, half of that, and 0.75 moles, half of 1.5 moles of hydrogen, and 0.5 moles of ammonia, remember, remain behind because only 50% of it is dissociated. So if you add all that up, it's 1.5. The answer is A. Which compound is not an isomer of the following compound? So look what I've got. I've got 1, 2, 3, 4 carbons and 1 oxygen. 4 carbons on each of those corners. Now how many hydrogens are on each? Well, each carbon's got 2 bonds there, so there must be 2 hydrogens as well to have the carbon have 4 bonds. So 1, 2, 3, 4, 5, 6, 7, 8. So it's C4H8O. Which one is C4H8O? Answer is D. Is the only one that's not an isomer. They're all C4H8O apart from D, which is C4H6O. So the question says which is not an isomer. The answer is